Okay, now let's talk about the hybridization. To get into the hybridization, I want you to take a look at two types of bonds. First, sigma bond, and the second, the pi bond. What are sigma bonds? Sigma bonds are the first bond made with any other atom, whereas pi bond is any second or third bond made with any other atom. Now let's take an example. Here's the molecule that I just created right now, and I don't know the name of it. But the purpose of making this molecule is to show you how to determine whether it's a sigma bond or a pi bond. So whenever you see a single bond, that's called a sigma bond. So that sigma, one of them is sigma, that's sigma, that's sigma, that is sigma, that is sigma, that is sigma. Now, one of them is sigma, and this is a sigma. Now let's take a look at the pi bonds. So the second one between carbon-carbon atom is the pi bond. The second and the third one is again the pi bonds. Now let's take a look, what are these sigma bonds made from? They are made from the hybridized orbitals, whereas pi bonds are made from the leftover p orbitals. Now I'm going to show you three examples of each: single bonds, double bonds, and triple bonds. So here's the example. As you can see, now let's take the example of single bonds. So as you can see, this is sigma, 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 sigma. They are made from the hybridized orbitals. So when we hybridize the normal atom of carbon, we need to have 4 openings for 4 sigma bonds. When this carbon that has only one sigma bond hybridizes, the 1s orbital left alone, whereas and the 2s and 2p's combines to make the 4 openings for 4 sigma bonds. 1, 2, 3, 4. That requires 1s and 3p. We end up with 4 sp3 orbitals. Now when a carbon makes a double bond, however, it makes 3 sigma bonds and 1 pi bond. 1, 2, 3 hybridized orbitals needed for sigma bonds, and 1 leftover p bond is needed for pi bond. Remember, as I said, pi orbitals are made from leftover p orbitals. So when this hybridizes, 1s left alone again, and we need 1, 2, 3 sigma bonds, and to hybridize in 3 equivalents 2p orbitals, and we need to leave one of the 2p orbitals alone. Now we got 3 sigma bonds or single bonds and 1 opening for the double bond, or we can say pi bond. Now finally, what happens when a carbon makes a triple bond or 2 double bonds? These are the same case. So as you can see, a carbon has a sigma bond with H and 1 sigma bond with N and 2 pi bonds, because the second and the third both count as the pi bonds, whereas in the other example there are 2 sigma bonds and 2 pi bonds. So when you hybridize, you get 2p orbitals for pi bonds and 2 sp orbitals for 2 sigma bonds and 1s orbital left untouched. So after seeing all these examples of each bonds, now I'm pretty sure that you can hybridize any other similar example easily. And also I have to tell you guys that single bonds can rotate, but double bonds or triple bonds cannot rotate. So in conclusion, when carbon has only single bonds, it has 4sp3 hybridization, and when carbon has 3 single bonds and 1 double bond, it has 3sp2 hybridization. And when you have triple bond, you need 2sp orbitals hybridization for 2 sigma bonds and 2p orbitals for 2 pi bonds.